How's it going, Eliminators? Today, we're going to be working on a Craftsman riding lawnmower that came into the shop not starting due to an electrical issue that I'm going to be taking you through all of the steps on how to properly diagnose. So with that being said, let's get right into it. So this is the Craftsman riding lawnmower that we're going to be working on today. Again, it will not start due to an electrical issue that I have already diagnosed. However, in today's video, I'm going to be taking you through every step that I did to diagnose this electrical issue so that I can go ahead and repair this machine and get it up and running again. Now, whenever you're working on an electrical issue, you always want to start at the battery. That is going to be the source of your 12 volts. Everything starts here and ends here. We have our battery positive and we have our negative, and I'm going to be showing you guys how to do some simple tests to test the battery, the cables, and then the rest of the circuitry without having to remove any electrical components. Now, to do these tests, I'm going to be using just a cheap Mastercraft multimeter here. We are going to be setting the multimeter to 20 volts DC because that will read anything under 20 volts DC, which is direct current, which is this battery here. Now, to allow me to film with one hand and conduct these tests with the other, I've selected just an alligator clip for my positive end and then just the basic probe style end for the negative. That'll allow me to go ahead and clip onto my battery positive just like that, and then I can go ahead and take my ground and touch it to the negative on the battery terminal there. And what we're doing is basically getting a baseline. So you can see that this battery has 12.75 volts. I charged this battery last night so that I had a fully charged battery for today's demonstration. So now that we've tested to see what the voltage of our battery is there, we've established what is known as our baseline, which basically means wherever we're testing an electrical circuit on this lawnmower and we're looking for 12 volts, we should have approximately 12.75 volts. If we were testing something to see if it had 12 volts and it had significantly less than that, that could mean that we have a corrosion issue on one of the connectors. Now, testing a battery with a multimeter to check the volts of the battery sometimes may not be enough, because this is a lead acid battery. Inside of this battery is going to be acid and lead plates. Sometimes those plates can get sulfated, and basically that just means a bunch of crap covers those plates, which is going to decrease the performance of your battery under load. So that's why I'm going to be conducting a second test using my battery load tester. Now, I did a video on this, and you can click on the top right of your screen to see that. Watch it after if you'd like. Basically, in that video, I had a battery similar to this one that I tested, and it tested at over 12 volts. However, when I put a load onto the battery by flipping that switch there, the voltage of the battery dropped to 0. Basically, the battery was completely useless. So it would test for 12 volts and it would appear with a multimeter like it was a good battery. However, if I would have used that battery on a lawnmower and turned the key switch to engage the starter, well, nothing would have happened, and you would have thought that because the battery tested good, that it wasn't a battery issue. So this is a good tool to do that test. Basically, we can see that we are over 12 volts right there, and I'm going to flip this switch. Basically, it puts the current through a large resistor here and puts a load onto the battery, and we're going to flip it and hold it for about 5 seconds. Now, you can see here that the battery is going to the bad, right? So this battery is on its way out. Now, if you had a battery that was similar to this where, it tests for over 12 volts and it shows you that it's a good battery and maybe the battery is on its way out, you could go ahead and put a battery charger, which I have just down there, onto the battery and then reestablish your baseline. So again, positive connector there. I'm going to touch this to the negative and we're going to look, and we can see that we now have 13.33 and rising because the battery is charging. That's going to be known as a surface charge. So if we leave this battery charger on, anywhere we test on this riding lawnmower, we should have 13 volts or higher, and then we know that we're good. Now, like I said, I've already established what the issue is on this riding mower, and I can assure you it is not the battery, because I tried to start it with a battery booster pack on it, and it still wouldn't start. So we've ruled out the battery. However, there could be an issue with your connections. So you have your positive post and your negative post. Off of the battery, you're going to have a cable that's usually black in color. You guys can see it right there. This is your ground cable that hooks to the negative, and then it goes down to the frame or the chassis of your riding lawnmower. This establishes what is known as a common ground, so that any circuit that is mounted to this riding lawnmower can use a ground going back to the frame. So you'll always see a little black wire with a screw going into the frame or on a bolt on the engine block, and that is what's known as your common ground. So we've tested the battery. The battery is on its way out. However, we have a battery booster to it, and the mower still didn't start. We have over 13 volts supplied to the battery now. So what is going to be our next test? Well, we want to test the connection between the battery negative here and the frame. So what I'm going to be doing is a simple resistance or continuity check between the negative post on the battery and somewhere on the frame that's basically going to be exposed metal. And you could use something like this bolt here for the seat spring that goes through the metal frame. Going back to our multimeter, we are going to take the multimeter off of DC and we're going to bring it down to our continuity test. Now, you could also test for ohms, which is going to be testing resistance. We'll get to there in a bit. However, we're going to be testing on this little symbol right there. That's continuity. Basically, when you touch the two probes of the multimeter, this should go down to about 0 to let you know that there is, in fact, a connection. That means that you have what's known as a closed circuit. The circuit is making a loop. If you had what's known as an open circuit, then you have a break somewhere in the wire. Or if we test on resistance for ohms and you have high resistance, that means that one of your battery cables could be excessively corroded, like that one there, but we're going to get back to that in a minute. So what I've done here is I've essentially just taken the alligator clip and I've put it onto the negative terminal that is connecting to the battery. And then I'm going to take the black one here and we're just going to touch this to the bare metal on that bolt for the seat spring, and we're going to go over to our multimeter here and you can see that it goes to 0. So what does that mean? Well, it means that we have over 13 volts at our battery and we have continuity between our negative cable right there, that's our ground cable, and the frame. So that means that the ground cable is good. So let's say you had an ATV and you turned the key on. Normally your lights would illuminate and your dash would illuminate as well if you had a digital dash. Let's say that on your ATV, when you turn the key, nothing happens. You don't get any lights illuminating. Well, one of the common issues on ATVs and some riding lawnmowers is you're going to get excessive corrosion on the ground cable connection that goes to the frame. On ATVs, usually that just happens because they're being submerged in mud and water, and the connection gets so bad that it either breaks away or gets so heavily corroded that it increases the amount of resistance, which we could do a resistance test as well, just to prove that the condition of the connector is not bad, because if we saw a bunch of corrosion here, that could be an issue. So coming back down to our multimeter, I've set the multimeter to 200 ohms. So we're going to be testing under 200 ohms of resistance right there. If it was a higher resistance level, you would have to go up. So we're going to be testing anything under 200 ohms of resistance. The red alligator clip is still connected to the ground cable, and then we're going to go to the bolt and we're just going to make sure we have a solid connection there. And we're going to go back over to our multimeter and you guys can see that we have 0.5. So we have very little resistance between our battery ground cable and the frame itself. So we can rule out a bad ground as one of the possibilities of our no start situation. We've tested our ground cable to the frame and it is good. So the next thing we're going to be testing is, you guessed it, our positive connection. Now, a lot of you may not know this, but from the battery's positive connection, there's going to be a long red cable. And on these Craftsman riders, they go all the way down the frame to, not this cable, but your starter solenoid right here. So I'm going to give you a crash course on how one of these starter solenoids work. It's incredibly simple. We have our 12 volt positive cable right here. From this 12 volt positive cable, there is a tiny little red wire. So this always has 12 volts. That tiny little red wire goes out of here and usually goes down to a fuse box right here. Your fuse then makes a connection to another red wire that goes up to your key switch. This is what provides your key switch with 12 volts. When you turn your key into the third spring-loaded starting position and it sends 12 volts down on this particular mower, what is going to be this white wire right here. And that powers an electromagnet inside of your solenoid. Now basically, a solenoid has a little metal rod, and when this solenoid is powered with 12 volts, the electromagnet lifts that metal rod and makes a connection between your battery positive and your starter cable, which is right there. Now on riding lawnmowers, there are going to be some safety switches that will prevent your lawnmower from turning over if those safety switches are not engaged. In the case of this lawnmower, we have a brake switch. So we have to depress the brake and then engage the parking brake lever up on the dash there. So just to show you what our problem looks like, we still have the battery booster supplying over 13 volts to our battery. Our parking brake is engaged, which means that the safety switch on the brake is engaged. I'm going to come over to the key switch and we're going to turn it into the third spring-loaded starter position, and you're going to listen for the sound. So we can hear our solenoid clicking, which means the electromagnet is powering and that rod is going up and down, which should be making a connection between our starter cable there and our battery cable there. So why isn't our engine turning over? Well, we have tested the ground cable, but next we're going to be testing the positive cable because, again, going back down here, it doesn't look all that bad. However, excessive corrosion could cause an issue. So the next thing we're going to test is that red battery cable from the battery positive terminal down to our solenoid positive right there. So we're just going to quickly reestablish our baseline, and you can see that 20 volts DC, our battery being charged, is now at 14.64 volts. So we're going to remove the rubber protective boot from our battery positive cable there, and I'm going to take my alligator clamp lead and attach it to the battery positive terminal on the starter solenoid. Now, we are still going to be testing for 20 volts DC on our multimeter, and now that we have that connection there, you have to remember that goes back to our battery positive. We need to find a common ground to see if we have 12 volts at that wire. If we do, that'll let us know that that cable is good. So on this particular machine, we have one of the engine mounting bolts, which is exposed metal. So I'm just going to touch that connector there, and then I'm going to go over to our multimeter here, and you can see that we have 14.62 volts. So essentially what we've done there is tested the connection between the battery positive terminal on the starter solenoid going all the way back to the battery positive post on our battery back there. And we've established that it is in fact sending 12 volts down. So that cable is good. We could do a resistance check on it just to verify that there isn't an excessive amount of corrosion on that cable, and I can show you that now. Now, because we're not trying to test the connector itself, we want to check the connection between this cable and the battery positive post. We're going to go to the bolt on the battery positive, and then down here at the starter solenoid, we're going to grab a hold of our lead here that fell, and we're going to touch it to that post there. But first, we're going to have to set our multimeter to 200 ohms of resistance. Go ahead and make the connection right here. I'll just do it on the bolt there. And then you guys can see that it is 0.3. So it's even less than the ground cable, which means that the little bit of battery acid that's formed on this battery positive connection there is not causing any issues with the 12 volts going to the battery positive terminal on the solenoid. Next up, I'm going to show you how to easily test your fuse and your key switch at the same time without having to remove any electrical components. So this is what I call a 4-post starter solenoid. You have one terminal for your battery positive, you have a second for your starter cable, we have our battery positive cable, that's the white one, and that comes down from the key switch, and then we have our ground cable right there. So that is what I call a 4-post. Sometimes there's going to be a 3-post, so you're only going to see one of these tabs. What that means is you still have your 12-volt wire coming down from your key switch. However, instead of having its own ground cable, the starter solenoid is going to ground through the base of the solenoid to the chassis of the lawnmower. Now you can see where that could cause some problems, because if you get a little bit of rust between the bare metal on your chassis and the starter solenoid, your starter solenoid would not have a good ground. So that's why I generally prefer these 4-post ones, because you have your own ground, and then we can go ahead and easily test that without having to remove anything after we test our battery positive wire. So coming back to your multimeter, you are once again going to set it to 20 volts DC. And what I've done is pulled the white 12-volt power wire to the solenoid. That's the one that charges the electromagnet. And I've stuck a probe in there. And then I've gone to our common ground, that is going to be our engine bolt right there. And what we're going to do is, once again, with the brake in the parking brake mode, we're going to turn the key. So I'll try to get a shot of this, and you're going to hold it. And you can see that when we turn the key, we are getting 14.64 volts to that white power wire. Now that's why our solenoid is clicking. So doing that little test, we've essentially tested 3 different electrical components without having to remove anything. We've tested the little red wire there. Now, depending on your manufacturer, you are either going to have a fuse box before the key switch, like we do here, or you're going to have a fuse box after your key switch. So just to run you back through this once more, off of the battery positive terminal on the starter solenoid, you have that little red wire. On our lawnmower, that goes to a fuse box with a 30 amp fuse. From there, that little red wire goes up to power 12 volts at your key switch. When you turn the key to the 3rd spring-loaded starter position, it travels down that little white wire, which then supplies power to our starter solenoid there to engage the electromagnet. So when we turn the key, you guys saw we had over 14 volts at that white wire. So we've tested that entire circuit, right? And the circuit is okay because we have over 12 volts. We've also tested our fuse down here, which I could show you later how to test one of these fuses. It's simple. You just pull it out and do a resistance test between the 2 tabs. But because we have 12 volts here, we know that the fuse box is good. We know that the entire circuit from the key switch down to here is good. And we also know that the key switch itself, when we turn it into the starting position, is good. So we've essentially tested the starter switch without having to remove anything. Now, in the event that you perform that test and you don't have 12 volts at that little white wire or red or orange that powers the electromagnet on your solenoid, you could have a multitude of issues. You could have a bad key switch, you could have a bad fuse, or you could have a bad brake switch. Because again, if you don't put your foot on the brake, power will not be sent to the solenoid to charge the electromagnet. So in that case, you would go ahead and remove the fuse, and then I'll just show you how to test that quickly. Basically, you just want to set your multimeter to continuity, which is that little symbol there. And then, like I said, hook up the leads to either end of the fuse, because just looking at it visually won't always tell you that it's good. And then what we're doing is looking to make sure that there is in fact continuity, which we have 0.03. So we know that there is in fact a connection, because if I let go of that, it will go to nil or null, whatever you want to say. Basically, we've now broken the connection off of the multimeter. But that lets us know that the fuse is good. So in the event that you don't have 12 volts at that little white wire there from your key switch, go ahead and test your fuse. Now, if you tested your fuse and the fuse tested okay, You could go ahead and make sure you have 12 volts coming in and coming out of the fuse box, because I recently worked on a lawnmower that had a lot of corrosion built up in the bottom of the fuse box. So I had 12 volts coming in and I had a good fuse that I inserted in, but because there was so much corrosion, there was actually no 12 volts going out of the fuse box, because two of the prongs on the one side had seized in the open position. So when I stuck the fuse in, it wasn't making a connection. Basically, I had to go in there and clean up all of the corrosion, and then I used some Permatex dielectric grease to go in there, and that prevents corrosion on electrical components. But you could do a simple 12 volt test on this fuse box. It's very simple, and I'll show you how to do that. So on this mower, we have our little red wire coming out of here, and we know that there's 12 volts here because we tested that. So all you have to do is trace this wire down to the fuse box, and that's going to be your hot side. And then you want to make sure that there's 12 volts coming out of the fuse as well. So you could go up, in this case, it's another red wire that goes up to the key switch. You could back probe the key switch to see if you had 12 volts there. And if you did, then you know that it's a bad key switch. If you didn't, then you know that you might have some corrosion at that fuse box there. So in the event that you tested the fuse, you tested those wires, you have 12 volts before your key switch, but for some reason you don't have 12 volts after your key switch, I have my own separate video on how to test every single terminal and every position on that key switch. I will link that video in the top right of your screen. You can click that and watch it. If the key switch is bad, you can go ahead and replace it. And if you still have issues after that, you can continue with your electrical diagnosis. Or if the key switch is good, then you can simply rule it out, and you may have some type of wire that is shorted to ground or, disconnected entirely. Now, in the event that you've tested everything that I just did, and no matter what, you do not have 12 volts at that solenoid charging terminal there, that little white wire on our machine, then you could have a safety switch issue. So even if you depress your brake, if the safety switch is defective, it won't be connecting the circuit or disconnecting the circuit depending on how it's built. Then I have a video on how to test a safety switch. I will link that in the top right of your screen as well, so you can go ahead and check that out. Basically, this video is just to show you guys that an electrical diagnostic on a riding lawnmower isn't some majorly complex thing. I know that it looks pretty difficult, but when I break it down like this, hopefully it makes a lot of sense, because you're going component to component. And whenever you're dealing with an electrical issue, you always have to start at one end and finish at the other. So we've started at our battery and we've ended up now at our solenoid. We know that we have 12 volts, or in this case 14.65 or whatever it was, going to our solenoid. When I turn the key, you guys could hear the solenoid clicking. So the solenoid is being powered. The electromagnet is sending that bar up to make the connection between our battery positive and our starter cable. So why isn't the starter turning? We've tested the positive, so we're going to test the negative. What we're going to do now is, you guessed it, a continuity or a resistance test between this black ground cable here and our frame. So with our one probe on the black ground wire there, we have our other red connector set up to our common ground, which in this case was our engine bolt right there. And then going back down to our multimeter, I've set the multimeter to continuity, and we do in fact have a connection. So we can rule out the starter solenoid's ground as a possible issue. So we've connected the ground because we know that's good. We know the white wire is sending more than 12 volts to the solenoid. We know that we have 12 volts at one side of the solenoid. We know that the solenoid is clicking, so the electromagnet is lifting that bar. However, we're not getting 12 volts or more to our starter. So what I've done is hooked up my one lead, my alligator clip, to the starter side on the starter solenoid. So what we're going to be doing now is simply a quick continuity check to make sure that this cable is in fact connected and that there isn't a break internally, which normally would be quite rare. But again, touch that to there, and we do in fact have continuity. So if I remove the probe, then it would look something like that, which would indicate like a break in your wire, but that's not the case. Now that we've tested continuity, we know that the wire is okay, but let's test the connection itself by testing 200 ohms of resistance to see if the connector is corroded, because you may build up a lot of gunk. You guys can see there's probably a little bit of oil leak, and then all the grass and dirt sticks to it. So with the connector still hooked up on the starter terminal on the solenoid, I'm just going to take this probe here, wipe off all the gunk, and we're going to touch it to the bolt there. And then again, we're testing 200 ohms of resistance, and we have 0.7, 0.8. So it's hardly anything. So that means that we do have a good connection to our starter. So is it an issue with our starter? Because again, like I said, when you're doing an electrical diagnosis, you have to start at one end and end at the other. A lot of times, one of the last things you test is going to be your issue. Basically, I have a video showing you how to bench test a starter. It's quite simple. All you need to do is put power here, and then you ground through the base of the starter. So that's where it bolts to the engine. Again, your engine is your common ground. It goes to the frame goes back to the battery negative. I normally do that with my battery booster pack. Unfortunately, the battery went on that thing, so I'm not going to be able to test the starter. Or instead of testing it here, because we already know that the cable is good, we can do a 12-volt test on the starter side of the solenoid right there. So with the positive alligator clip hooked onto the starter side of the solenoid, I have my ground going to the engine bolt right there, and I have this multimeter set to 20 volts DC. I'm going to turn the key and hold it, and you guys are going to see there's nothing. You guys can see that, well, it's looking like it is a solenoid that's the issue. And I'll just go back to the positive side to show you guys that, well, we have 15 volts now because the battery's been charging. So as you guys can see, the solenoid does look like it is defective. I've taken you through pretty much all the tests you would need to do to get to this point here. So why would one of these starter solenoids fail? Even though when we charge the electromagnet by turning the key switch and supplying the solenoid with 12 volts, we can hear it clicking, which means the electromagnet is engaging, and that rod should be making the connection between our battery positive and our starter cable. Well, what happens on a lot of these riding mowers is they sit outside, and what will happen is these starter solenoids develop moisture inside of them. That moisture turns to corrosion and rust. And to prove that, we just did that simple 12-volt test to see if we were getting 12 volts or more at the starter wire, because we know we're getting 12 volts there and we can hear the solenoid clicking, and we're not getting anything at the starter wire. You guys saw 0 volts, which means this thing is just so filled with corrosion that the bar or rod that rises to make that connection simply cannot make the connection. Now, if you'd like to do a further electrical diagnosis on your starter solenoid, you can go ahead and remove it to do what's known as a bench test. I do have a video on that, which I can link in the top right of your screen, so you can watch that. Basically, there's going to be 2 bolts that hold these starter solenoids onto the chassis. They're located on the other side of this piece of metal here. You are going to have to disconnect one of the terminals at your battery, though, because we have to remember that we're getting more than 12 volts here. So if you were to take this off and touch it to the frame, you could get some arcing. So go ahead and disconnect either your positive or your negative terminal at the battery so that you don't have any power coming here. You can go ahead and take both of these cables off. Go ahead and unplug your power and your ground up there. Remove your solenoid. Basically, you're just going to be powering it with 12 volts to engage the electromagnet, and then you're going to be doing a resistance test between these 2 terminals here, and basically that'll be the same thing as doing the 12-volt test to see if we had 12 volts at this side. We don't, so that just means that I have to go ahead and replace this solenoid. And I have in front of me here a Stenz starter solenoid. This is what they call a double pole, or what I would call the 4-post solenoid. The part number is a 435-435. So what I'll do is go ahead and remove that starter solenoid, then get this one installed, and that should solve our issue. And then once we turn our key switch, the starter should turn over because we will be getting 12 volts at the starter cable. So I know it can seem a little overwhelming at times, but hopefully I've supplied you with enough material here to be able to confidently diagnose your own riding lawnmower's electrical issues. And if you don't have enough information in this video, you can go to the sub videos that I've linked today in this video, Or I will also link my electrical playlist, which has every electrical video that you would ever need to go through pretty much any electrical issue on a riding lawnmower, whether it be an electrical PTO, a key switch, a safety switch, anything you would need. My electrical playlist will have all of that. Well, that's going to wrap up today's video. Like I said, if you follow all of the steps that I showed you, then you should be able to properly diagnose your own riding lawnmower's electrical issues. With that being said, if you guys enjoyed the video, think about leaving me a thumbs up. You know, it really helps me out. You can click here to subscribe and click over here to watch one of my previous videos. I upload every single week, so be sure to stop on by next week, check channel out for new content. And as always, guys, thanks for watching.